Okay guys, so today what we're going to do is we're going to look at invariant points. This is where a point doesn't change during a transformation. By the end of this video, you should understand what I mean by this and how to identify an invariant point after a transformation. So let's start with this one. Shape P is transformed so that at least one vertex is invariant, or rather exactly one. Which transformation could have been used? Well, let's try all of them and then we'll talk about whether they're correct or whether they're incorrect. So let's start with a reflection in y equals minus 2. So if we reflect this in y equals 2, right? And we'll call this one A, B, C, and D. You can see that the only things that change are C and D, right? And A and B are both invariant. But here's the thing though. Here we need exactly one, but for this reflection we have two invariant points. Okay? So this is not the right answer. Let's try rotating it center to 0 and 180 degrees. Okay, so we're left with a point here and let's rotate. So this would be B prime, A prime would go here, C prime would go here, and finally D would go here. So as you can tell, none of the points are as they say they are, right? They are all non-invariant. So this one has 0 invariant points. Do you understand? It's because this points, they are not the same as what they were at the start. Okay, what about if it's a enlargement, scale factor minus 2, center 3, 2? Well, let's look at 3, 2, which is here. I'm going to use a different color here. That's B. Alright, so this is the point of enlargement. And it's scale factor minus 2, so we need to make everything flipped. So this B will stay as it is. A would go, A would be here, right? This is A double prime. D would go here. And finally, C would be here. Yes. Okay, so D would be here. Excuse me. But what do you notice? The only point that has not changed throughout this enlargement is B. Because B is an invariant point. And so the answer is C. Now, what about the translation though? Translation can never have invariance because the entire shape moves, so therefore translations can never have invariance. They are always going to change. Let's look at some exam questions though. For this one, we're told triangle A is transformed by the combined rotations of a 180 degree rotation and the translation of vector minus 3, 2. In that order. So one of the points of triangle A under the combined transformation is invariant. Which point is it? So, okay, let's first and foremost rotate this shape. So, minus 2, 0 is here. If I call this X, Y, and Z, then X is gonna go here, Y is gonna go here, and Z is gonna go here. Okay? Don't ask why I 2 primes them, but that's another story for a different day. Okay. So here, now we're going to do minus 3, 2. So we need to go 1, 2, 3 to the left, and then 1, 2 up. So this point here is X. This is actually X2 prime. I don't know why I put X2 prime here. That was a mistake. Y 2 prime is going to go 1, 2, 3, and 1, 2, 3. So this is Y2 prime. And same with Z. Z's going to go 1, 2, 3, 1, 2. And so this is our new triangle. Which one of the points are invariant? Well, think outside the box, guys. It can't be this point here because X was here when it started, right? Same with Y. But what about the point in the middle? That hasn't changed. So the only point of invariance is going to be minus 3.5, 1. Okay? What about this point? So for this one, we're told square ABCD is transformed by combined transformation of reflecting the line y equals minus 1, followed by a rotation. Under the combined transformation, 2 vertices of the square are invariant. So let's find out which rotation it is. So let's first reflect the point x equals minus 1. So A prime is going to go 1, 2, and then 1, 2. So this here is A prime. Same with this point. It's going to go here, which is D prime. I'm doing 2 primes today. I don't know why, but let's just roll with it. B is going to go 1, 2, 3, 4, and 1, 2, 3, 4. So this is B prime. And finally, C is going 1, 2, 3, 4, and 1, 2, 3, 4. So this is C prime. So now, what rotation could you use in order to make this the same? And very important, we need these points to be invariant with A, B, C, and D. Which 2 points can we pick? Well, what we can do is rotate it. But where are we going to rotate it? Okay, it's going to take a bit of trial and error. But I think one way you can do it, and if you find a different way, be sure to use that in the comments down below. Is what we can do is we can rotate this shape 90 degrees and we can make B and D invariant. Let's see how that works though. So I've already spoiled it. So this is going to be D2 prime and this is going to be B2 prime. What about A and C? So let's take a look. So A is going to go from here to here. So this is going to be A2 prime. And C is going to go from here to here. So this is going to be C2 prime. And as you can see, only D and B are where they were when we started. And so therefore, B and D are the only two vertices which are invariant. What about this one? So for this one, we're told that we already completed a transformation of this triangle. B is invariant. A moves to 1, 1. So where's 1, 1? 1, 1 is here. Call that A prime. And C goes to here. C, 2 prime. So what is a single transformation that turns this shape into this shape? Well, from what I can see, it's a rotation. It's going to be 180 degrees. And it's going to be center of rotation. We don't even need to do anything. Because for a rotation to have a center of rotation, has to be one of the invariant lines. And we know that it's at B, so the center of rotation is -1, 1. And that's all there is to it. Thank you guys for watching. I hope this video made sense. If you guys liked it, consider subscribing as it helps out the channel a lot. If you have any further questions or comments, or you're stuck with an exam question, join my Discord server. It's the best place to get all your exam grievances catered to. If you guys really don't want to fail your exams and you want to pass to make your parents proud, drop me an email so that you can be tutored by me. Keep on learning, as you have no idea what you're capable of doing.